This assessment asks us to rank the 6 bonds shown based on the strength of their bond dipole. And we're going to rank them with 1 being the weakest and 6 being the strongest. Now, on a problem like this, what probably matters most is being able to qualitatively look and see that, for example, fluorine is highly electronegative, so it's going to represent a relatively polar bond, or it's going to make a relatively polar bond with carbon. But because we can answer this quantitatively, I've put the Pauling electronegativity values on here for each, and this will allow us to look at the difference in Pauling electronegativity values for each of the 2 attached atoms and get a more quantitative measure. Again, what matters most, though, is the qualitative understanding of what the numbers are telling us. So if we look at the carbon-fluorine bond, we can recognize that that's a bond between an atom with an electronegativity value of 4 and 2.5. So we could put down here that that difference is 1.5, which is going to tell us how polar that bond is. So the difference in electronegativity value of 1.5, that's pretty significant. This is going to be a relatively polar bond. If we do the same thing for carbon and bromine, we've got 2.8 and 5. That difference is going to be 0.3. For carbon and iodine and carbon have the same Pauling electronegativity value. So even though iodine is a halogen, it's actually a non-polar bond in terms of these Pauling electronegativity values, the difference being 0. The carbon-hydrogen is going to be a difference of 2.5 and 2.1. And so this difference is 0.4. In terms of the bond dipole of the carbon-hydrogen. We don't usually think of that as a polar bond, and it's not really a polar bond, but it's certainly not purely covalent like the carbon-iodine and carbon-carbon one would be. Carbon-carbon, as we said, 2.5 and 2.5, that one's going to have a difference of 0, and carbon-chlorine, 3 and 2.5 for a difference of 0.5. And so if we look at the weakest bond dipole, that would be a tie between carbon-iodine and carbon-carbon. So we'll call that tie for first, which means the next one would be third. The third is going to be the carbon-bromine, carbon-hydrogen, carbon-chlorine, and the strongest would be carbon-fluorine, exactly what we would expect based on electronegativity difference. So the carbon-fluorine bond is significantly more polar than carbon-carbon and carbon-iodine.